My name's Charlie Luxton. I make television programs about architecture, and I also run a sustainable architecture practice, Charlie Luxton Design, which is based here. This is our offices. Charlie Luxton Design is an architecture practice I've run for the last 20 years. We focus on sustainable architecture, and we have done for a long time. So really, that means sort of energy in use and energy in construction. So we were a practice of about 10 people working in a very small thatched cottage. It was really busy, it was really packed, it used to get very stuffy. It was lovely. It's a listed thatched cottage. We did a very deep sustainable refurbishment on that about 12 years ago, so it was lovely and warm, but it was not really right. We needed a new home. Very fortunately, the property next door to us, which was a 3.5 acre field and a steel shed, basically an equestrian sort of place with lots of horses, came on the market, and it was like, okay, great. I think for planning we can make equestrian into office. We need an office, so we bought the field and the shed. And we wanted to create a home for the practice that sort of was a summary, a manifesto of all the things that we believe in about architecture, and to create a healthy, sort of well-lit, spacious place for us to work. You know, I think the office is probably one of the most important tools that you have in the armory of any business, in that you get so much more out of your staff if you're in a healthy, nice environment. I think people are happier, they're healthier, they stay longer. And you know, when you look at the cost of owning and running a office building, it's all fees, it's all wages. So if you can get your staff to work well and be happy, that's great for the business. And the best way to get staff to work well and be happy is to be in a healthy, well-lit, you know, warm, nice environment. So we really wanted to try and kind of embed that into where we worked. We wanted to create a very low energy building, both in use, so passive equivalent, and in construction. So we're really focused on the amount of energy that we use to make the building and then to run the building. So it's incredibly well insulated. It uses the existing concrete slab that was in the old building, the frame that was in the old sort of steel barn. We've built inside that with a very highly insulated timber I-beam structure, very airtight, mechanical ventilation, heat recovery, air source heat pump. And then we've put a 20 kilowatt PV array on the roof to provide the lion's share of the energy for the building through the year. And then we've just used a lot of thermal modeling to refine the opening sizes, orientation, shading, so that really the building operates very low energy and it's very comfortable to be in. We've been using mechanical ventilation heat recovery, MVHR, for many years. I think it's a fantastic part of the armory, the kit, the tools, if you like, for low energy building. For me, there's three sort of main things: super amounts of insulation, really good air tightness, thermal modeling, and MVHR. They're the great step forwards within sort of architecture over the last 15, 20 years. And the reason MVHR is so good is that once you have a highly insulated and airtight building, the air that you need to move through the building to breathe becomes a large component of your energy use, because you're losing so little energy out of the walls because of the thick insulation, triple glazing, and all of that kind of element of the build, the fabric, that actually providing fresh, clean air for everyone uses a lot of energy, the remaining energy that you have. And you can massively reduce that by using mechanical ventilation heat recovery. Beyond the energy side, it increases the ventilation levels that you would normally get in a building. So you've got more air that's fresher and filtered, and obviously you're stripping the heat that's in the air of the building that you're removing to preheat the fresh air that comes in. It just means that whenever you walk into a building, it's fresh. You know, it doesn't feel like the doors have been shut. It always has a kind of fresh, alive feel to it, I suppose is the way I'd put it. And crucially with an office, when you get build-up of CO2, people start getting a little bit sluggish, people's productivity starts to go down, they feel a bit sleepy, you know, they don't feel as awake. And one of the core things, or one of the key things that we've put in here is CO2 monitoring, so that as the CO2 levels rise, the MVHR just slowly picks up to maintain a kind of stable, low level of CO2 to help people work in the office. When you create near passive levels of insulation and energy demand in a building, you suddenly have the opportunity to use all different kinds of technology because the heat you require is so small that actually a lot of things become really efficient to use. So for example, in this building, we use the air source heat pump to provide heating through a DX coil on the supply side for the air. So as the air comes in, we warm it up and that brings the heat into the building. And what's fantastic about that is when it comes to summer, you can then run the air source heat pump backwards and you can cool the air that comes in. And the amount of energy that uses, even in the middle of winter, we're using like 1.5 kilowatts of electrical energy. And we've got a 20 kilowatt array on the roof. So even in the middle of winter, we should be producing 1.5, 2 kilowatts on a fairly grey day. So we can be pretty much zero imported energy to heat and cool the building pretty much all year. The benefits are many, there's many different ones that I think are worth sort of focusing on. Firstly, if you're in an urban environment, it's the filtration that you can get from the air that you're bringing into your house. So it comes into the MVHR unit, goes through a number of filters. And when you change those filters, which you should do regularly with MVHR, OMG, you just look at what is on those filters and you just think all of that would have been in your house. So it takes out a lot of particulates. It can take out not only from cars and soot from smoke from wood burners, etc., but also pollens and all these kind of things. It can really help with allergies. The other thing that happens with MVHR in houses is that it regulates the humidity very, very well. So it keeps humidity lower and more stable, normally at around 50 to 60%, which is really where you want it to be. Any higher than that, you start to moving into the realms where you might get black mold. When we're designing buildings with MVHR, we start integrating the MVHR system as early as possible into the design phase. Because you need to run, in some places, certainly in this case, quite significant amounts of ductwork through your walls and in your floors, and you need to think about that. It's really not complicated if you think about it early. And so here we designed all of the pipe runs quite early, and then we were looking at how we could fit those into stud walls above window openings internally, how we could get them into the floor, how we could fit everything in, so that when it came to installing, it was all relatively straightforward and easy. And I think that's the critical thing, is think up front, and then when you get to site, it should go really smoothly. So once the MVHR was installed and running and properly commissioned, and I think that's very important that people understand that having designed an MVHR properly and installed it properly, it must be commissioned properly. And there is a real art to properly commissioning and using the right equipment, the right monitoring equipment over the vents to make sure the airflows are correct. That needs to be done properly. Having done that, we have then tied the MVHR unit and the air source heat pump. The air source heat pump talks to the MVHR unit unit talks to our building management system. So I can access all the data about how the building is performing, CO2, humidity, temperature in all the different rooms, and then we can use that to control the MVHR and therefore the air source heat pump to try and keep the temperatures as comfortable as possible in the building. This overheating is something that we've been looking at with real focus for about 8 or 9 years. So we've done a lot of thermal modelling, and increasingly the thermal modelling we've done over the last few years is to stop overheating. The big issue is when buildings get hot, because if a building is cold, you can turn the heating up. Now that might not be great for the planet, but you can solve that problem relatively easily. When a building gets very hot, it is much harder to solve that problem. And so the government had realised this and brought in Part O, which is a new building regulations sort of area that covers overheating. And I think that most or a lot of architects don't quite understand the technical implications of it, and it is quite serious, and it's a great bit of legislation, in my opinion, because it means architects need to really take serious the fact that their buildings have been getting too hot. And it is great to have lots of glass and these grand designs kind of houses, but a lot of them just get too hot and they're not very comfortable to live in. And then people start putting in air conditioning, and that's really not what we should be doing. Full-on air conditioning is very energy intensive, and we can achieve a lot and reduce the demand for that a lot by just good design, thoughtful design. And Part O deals with that. So you now need to thermally model all of your buildings to understand if they're going to overheat. And the great thing about that is that if you're thermally modeling it to understand if it's going to overheat, well, it takes it almost next to no extra work to now thermally model to understand what the energy demand is, and suddenly all architects and designers are starting to having to think in terms of thermal modeling and actually analysing their building's heat demand prior to building them. That's a game changer, and hopefully it will bring a lot better architecture and quality of space to the new build sector. I've worked with Airflow for a long time, and for a number of reasons, and one of the main ones is that they cater for very small projects right up to very large projects. Okay, so they can provide for a massive scale of projects that you're working on, whether it be commercial or small residential. We've put Airflow units into tiny little 2-bed basement Bristol flats, right up to large scale 200, 300 square meter commercial buildings in larger houses, and they can deal with all of that technology, which is great. A lot of their kit's passive certified, which is a really good mark to have on any unit, because it's been tested, that the efficiencies are high, that it's a quality bit of kit. So that's another really good reason. And I've always had fantastic support from them, both in terms of design and then on sales support about getting it installed correctly, making sure that it's commissioned correctly. They're really good at following through on that detail. And as these things, occasionally there's issues, and they've been amazingly good at fixing them, which is completely, what you'd expect from a really good company like that.